In the last part of this chapter, we're going to be using systems of equations to solve word problems. Our goal will be to write a system of linear equations, like the ones we've been solving before this, to describe a real-life situation, and then use it to solve some problem. Since our goal in this section is going to be to write our own systems of linear equations, I wanted to remind you what they should look like. So here's a system of linear equations, like ones we've been solving, y equals 2x plus 8, and 6x minus 3y equals 24. And there are a couple of things going on here that you're going to want to make sure you have in the systems that you write. First of all, there are going to be two equations. So we've got two different equations. And each equation contains two variables. So we're going to be always looking for two equations and two variables. And the really important thing that, if you can notice, will make your life a lot easier is that the function of each equation, so what it does, is the first one tells us one relationship between x and y, and the second one tells us a different relationship between x and y. So two equations, each one has two variables in it, but what they do is they tell you a different way that the two variables are related. So in every problem we do, we're always going to be looking for two variables and two ways to relate them to each other. The best way to learn how to do this is to look at a few examples. So here's one. A bank teller has 112 $5 and $10 bills worth a total of $720. How many of each type of bill does the teller have is our question. And what we're going to do is write a system of linear equations to solve this situation. So remember, we're always looking for two variables and two ways to relate them. So our first step is going to be to look for the two things we don't know in this equation and come up with a variable to represent each one of them. So you should be able to tell by reading through this problem that the two things that we don't know is how many of each type of bill the teller has. When we're talking about each type of bill, we mean the number of $5 bills and the number of $10 bills. So we're going to define our two variables. And the way we're going to define two variables is we're going to say let, and then we'll pick a variable. So for $5 bills, we can pick f, so f for 5. And we'll say that let f equal the number of $5 bills. And we want to be very specific and say that we're talking about the number of $5 bills and not something else about them. And then for our second variable, we'll say let, and then we'll pick a letter. So we'll say t for 10. So t will be the number of $10 bills. And you want to be very specific so we know exactly what about each thing that we're talking about we mean. Now we have our two variables, and now we need two relationships between them. And your problem is always going to tell you two ways that the variables are related to each other. So let's see what information the problem has for us. Two things that the problem tells us about how the variables are related. Well, first of all, the problem tells us that in total there are 112 $5 bills. Because remember, our variables are the number of $5 bills and the number of $10 bills. So one thing this problem tells us is that the total number of bills, so that's the two of those together, is 112. So that's going to be really useful to us. So the total number of bills, that's 112. And another thing that it tells us is how much they're worth. So it's saying this is how many there are, but if you count up the value of all of this money that this bank teller has, you should get $720. So if we look again at our total value, that's not 112, that's something different, that's 720. So now what we're going to do is we're going to take each of these pieces of information separately. So the total number of bills is 112 and the total value is $720. And we're going to use each piece of information to write one of the equations in our system. So first thing we're going to do is just hone in on this first piece of information. The total number of bills is 112. So the total number of bills, you figure what that is by adding together the number of 5s and the number of 10s. So we know that f is the number of 5s and t is the number of 10s. And when you add those together, you should get 112 altogether. So just this first piece of information gave us enough to write this equation, f plus t equals 112. Now, you want to completely ignore what we knew from this piece of information, so I'm just going to cross it out, and think only about a new piece of information. The total value is 720. So we're going to use that piece of information to write another equation. So because it's a total and it's 720, we're going to say that this equation equals 720. And then you've got to think, okay, how do you get that $720? You're adding together the value of the 5s and the value of the 10s. And to figure that out, you say, okay, well, the $5 bills would be worth $5 times however many there are, and there are F of them. So $5 times the number of bills, F, would give you how much the $5 bills are worth. And then to get the total value, you'd add that to the value of the 10s. So every $10 bill is worth $10, and there are T of them, so that's the number of bills. So 10 times T would give you how much they're worth. When you add 5F plus 10T, that gives you the total value of the money that you have, so 720. And now at this point, we first of all use this piece of information to write an equation, completely disregarding the first piece. And now we have two equations. They both have an F in them and a T in them, and they both show a different way that F and T are related. So we have a system. And we could take the system and solve it using either substitution or combination elimination, find the value of F and T, and answer this question. We're not going to do this right now because we're just focused on writing equations. What we're going to do is look at another example and see if we can use this same method again. Second example is about a pet shop. This pet shop sold 23 puppies and kittens altogether in 1 week. And they also say, although they sold 23 altogether, they sold 9 more puppies than kittens. And they want to know how many of each did they sell. So we use the same method as before. We say, okay, we need to define two variables. So two things we don't know. They're asking you how many of each type did they sell. So we don't know how many puppies there are, and we don't know how many kittens there are. So we can say we'll use P for puppies. So P can be the number of puppies sold. So that's the question they're asking. How many of each did they sell? So one thing is P will be the number of puppies sold. And it's not hard to imagine that we can say K for kittens and let K be the number of kittens sold. So now we have two variables. And now we have to look into our problem and say, okay, what do we know about the way they're related? And so here's what we do know about the way they're related. First of all, we know the total number of pets, so that's the puppies and the kittens together. We know the total number is 23. So I'm going to say that one piece of information that I know is that the total number of pets is 23. And that's a piece of information that we will later use to write one equation. So there's one piece of information. So that takes care of this first sentence. Then we'll look in the second sentence, and it says they sold 9 more puppies than they did kittens. So that's another piece of information. So we can write down there were 9 more puppies than kittens. And this is another piece of information that we'll use separately from the fact that the total is 23 to write our second equation. Okay, so now it's time to write some equations. So we need to write our system. And we're going to hone in on one piece of information at a time. So first we'll say, okay, we know the total number of pets is 23. So you get the total number of pets by adding together the number of puppies and the number of kittens, because there are these two types. So we can say that P, the number of puppies, plus K, the number of kittens, is equal to 23, which is our total. And that's a really simple equation, kind of like saying the number of 5s and the number of 10s is 112. And we've used that piece of information. And now we're going to forget about it. We're going to forget that we know it and only think about the fact that we know that there are 9 more puppies than kittens. So the fact that there are 9 more puppies than kittens means that if we know the number of kittens, we have to add 9 to it in order to figure out the number of puppies. So this is just saying that whatever the puppies are, that's kittens plus 9. Or you could say that the puppies minus 9 was the number of kittens. But somehow you want to say that there are 9 more puppies than kittens. So kittens plus 9 will give you the number of puppies. So making this relationship took care of this piece of information. And you want to totally disregard the first equation when you're doing this because we're looking for 2 different relationships between the variables. Now that we've used both of these pieces of information, we now have 2 equations, each has 2 variables in it, and they show a different relationship between the 2 variables. So we have a system, which we could solve using either substitution or linear combination elimination, but we could find P, find K, and then be able to say, okay, they sold this many kittens and this many puppies, and answer our question. At this point, I'd like to give you guys a couple of examples to try on your own. So here's the first one. Tickets for the senior play cost $4 for adults and $2 for students. This year, there were 600 tickets sold, so that's the total number of tickets, and the class made $1,900. So the ticket sales added up to $1,900. And the question is, how many of each type of ticket were sold? So you want to pause your video right now, take a few minutes, and use the 3-step process. You want to go back and define your variables, write down your information, and then write your equations. So take a few minutes to try that. Define variables, write down your information, use each piece of information to write an equation. Now that you're done with example 3, I'd like you to try one more. Same directions, write but do not solve a system of linear equations that could be used to find the answer to this problem. The sum of 2 numbers is 5. The larger number exceeds the smaller number by 14. Find the 2 numbers. So again, define 2 variables. Write down 2 pieces of information about them. Use each piece of information to write an equation and get a system. You don't have to solve this system. You didn't have to solve the system in example 3. So try those 2, and then you're done for the evening. I'll see you at our next class. Good luck.